Okay, so good morning, student. Today, in the course of turbo machinery, okay, so we'll see numerical on boiler performance. Okay, we'll be taking numerical. Okay, simple numerical on boiler performance is there. In a boiler test, which is there, I have 1,250 kilogram of coal is consumed in 24 hours. The mass of the water evaporated it is 13,000 kilogram, and the mean effective pressure is 7 bar. Now the mean effective pressure is 7 bar. Okay, so this term mean effective pressure is there. We generally relate it with the inter when we generally use this term in IC engines, right? So where in IC engines the mean effective pressure means the pressure. Okay, so the effective pressure inside the cylinder, the mean effective pressure, the around kind of the average pressure inside the cylinder over my entire cycle, over one entire cycle, right? So here when am I talking about mean effective pressure, that is meaning that okay, my steam which is there, the steam that is generated, okay, so that steam which is there at different points which is there, the steam it would be having different pressures. So overall, okay, my if I overall which is there at one point which is there wherever my steam it is, so in my inside my boiler shell where the steam is just generating, so that time it may be the pressure may be a little higher, right? But at the time of the exit it may be slightly lower than the 7 bar. So overall over inside the entire boiler shell which is there, the average pressure of the entire steam that is generated, that is meant to be as 7 bar. Then the feed water temperature it is given as 40 degrees Celsius, and the heating value of the coal which is there, it is given as 30,000 kilojoule per kilogram. Now the enthalpy of 1 kg of steam at 7 bar is given as 2570.7 kilojoule. So this value is there. So otherwise, okay, in the other questions that we have already discussed, what we do from the value, from the temperature and from the pressure of the steam which is there, okay, so and we use the steam tables to get the value, to get my enthalpy of steam which is there. But here in this question my enthalpy of steam it is directly given, and I am supposed, and using these data, so I am supposed to determine the equivalent evaporation per kilogram of coal, and I am supposed to find out the efficiency of the boiler. Now, right now in this boiler I am not given that I have any other boiler accessories which is there, or any other data is not given. So I have to, and what I have to suppose, I am supposed to be considering that in this particular system, in this particular boiler which is there, so this does not have any of the accessories which are there, right? So it does not have any of the accessories, it is having just the boiler. So now we'll start the problem. Okay. So firstly, my boiler which is there, okay, so I am consuming 1250 kg of coal in 24 hours. So to start off with, okay, so firstly the mass of steam which is generated, okay, ms is 13000 kg for 24 hours. Got that was in my entire question, so nowhere else which is that my duration is given. So all the data that is given which is that is assumed to be for that I am can directly take it for 24 hours. Then mass of steam is given, then my steam condition which is there, okay. So second next which is there, okay, so as soon as I'm writing the mass of steam, then the steam mean effective pressure of steam. Okay, so here since that mean effective pressure is given, okay, so I'll take that term directly. The steam pressure we denote it as PS equal to 7 bar. Then I am given my temperature of the feed water. So the temperature of feed water, okay, so we are denoting it as T1 equal to 40 degrees Celsius. Then mass of coal. So the mass of coal, instead of let it be coal, let it be oil, okay, so let it be gas, any of instead of any of them, okay, so we are using a general term MF, which is denoting the mass of fuel with respect to whatever the fuel is, okay. So MF which is there, that is 1250 kg for 24 hours. Now, the enthalpy of the steam at 1 kg of enthalpy of steam at 7 bar, which is that I am directly given that. Okay, so the enthalpy of steam which is there, so that will be my enthalpy of steam at outlet, right? Enthalpy of steam at outlet, okay, which we are denoting it as H1. So that is 2570.7 kilojoule per kilogram. Okay, because it is already given that for 1 kg of steam. So I am taking kilojoule per kilogram. Then I am given the calorific value of fuel, which is there. My calorific value it is 30,000 kilojoule per kilogram. So have I taken all the data which is given? Yes. No. Just for the sake of just for the condition of discussion which is there. So my steam, I am given the enthalpy of steam directly here, and I know this. I know what is my steam pressure, right? So from the steam tables, okay, at PS equal to 7 bar. So why what I am looking for in the is that okay. So what will be my temperature of steam? Okay, so from steam is at 7 bar, which is there. Okay, so what I have to look at is my I can look at my temperature of steam, okay, or I can look at my enthalpy of steam. Now, what actually I am interested right now here is that what is the enthalpy of steam which is there. Okay. So now, because I don't know what is the condition of the steam here. My condition of the steam, okay, so it can be either wet steam. My condition of steam can be wet steam, or it can be dry steam, or it can be superheated steam, right? So we have these three conditions which is there, okay, for steam. So now we don't know that from which of these conditions, what is the condition of the steam? Okay, it can be either wet, or it can be dry, or it can be superheated. So how do I find that out? Okay, so I have to look for what is the enthalpy of the saturated steam which is there. Okay, what is the enthalpy of saturated steam at my outlet here? So now my enthalpy of steam which is there, okay. So let me note down the values I have. I'm given that my enthalpy of steam which is there. So the enthalpy of saturated liquid, that is 697.1 kilojoule per kilogram, and my latent heat of vaporization it is that is given as 2064.9 kilojoule per kilogram. Now, now from these two values which is there, so what will be my enthalpy of saturated vapor which is there? So my enthalpy of saturated vapor, it is just the addition of both of them. That is 2762 kilojoule per kilogram. Now, so just by observing, okay, so I can see that the enthalpy of saturated vapor, my enthalpy of steam which is here, okay. So the enthalpy of my steam here, okay, so that is less than the enthalpy of saturated vapor. So what can I deduce then? Okay, so the condition of the steam which is given, the condition of the steam that I am getting here, okay, so that condition of steam which is that is wet steam. So just by actually looking at the values for the enthalpy of the saturated steam, okay, enthalpy of saturated steam from my steam table for 7 bar, I can observe that the values which are there, okay, so this both of them, okay, so H1 which is there, that is less than Hg. So that means my enthalpy, my steam which is there, that is not becoming converting into saturated steam. It is still there is still water remaining it. So my condition of steam which is there, okay, so wet steam. The condition of the steam at outlet which is that is wet steam. So now when I am no wet steam, then along with the term of wet steam which is there, I can also be calculating what is my dryness fraction which is there. Okay, so the dryness fraction which is there, that is given by H equal to HF plus X into HFG. This is the standard expression which is there, which we have discussed already, which has been discussed in thermodynamics. Okay. So from here I know what I know my value of H which is there. Okay, so H is 2570.7, so implies 2570.7 equal to HF 697.1 plus X into 2064.9. So implies again what I can say is that my dryness fraction x equal to 2570.7 minus 697.1 divided by 2064.9. So my dryness students, my dryness fraction is there. I'll be getting it as 0.9073. Okay, so which I can assume it as 0.91. So what I can say, what I can deduce is my dryness fraction of the steam which is there. Okay, x equal to 0.91. So this part which is there. Okay, the dryness fraction of steam which is there. That is just for our information purpose. Okay. Now we'll come back to a problem. Okay. Now in my question which I given what is my total mass of steam which is there. It is evaporated in 24 hours. Then the mass of the fuel that is consumed in 24 hours. So I can find out my evaporation rate or my evaporation capacity. My evaporation rate which is there. Okay, which I am denoting, which we are denoting as MA, equal to as the expression of mass of steam upon the mass of fuel. Okay, so irrespective of the duration. So here my mass of steam it is 13,000 and my mass of fuel which is that is 1250 kilogram of fuel is consumed in 24 hours. So this becomes okay. So students, I can get it as 10.4 kg of steam which is generated. Okay, per kg of coal in 24 hours, because my entire duration, which is my entire duration for which I have assessed the performance, for which I have found out my performance which is there. Okay, so that is for 24 hours. So in this 24-hour duration I am getting 10.4 kg of steam for every kilogram of coal which is evaporated. Now before now we can proceed. Okay, so to proceed to equivalent evaporation and to enthalpy, so we'll be requiring one more term. Okay, so which is the enthalpy of the feed water. The enthalpy of the steam which was there, that was provided. Okay, so enthalpy of feed water at boiler inlet, or which we write as, which we denote as HF1, that is equal to Cp of water into T1 minus 0, because here at the inlet of the boiler which is there. Okay, so it is in completely in liquid state, and the liquid state which is there, the liquid state for the case of water which is there, my liquid state it is starting from 0 degrees Celsius, right? So the enthalpy that is gained from 0 degrees Celsius until T, so that is my enthalpy of the feed water at inlet, boiler inlet. That will be 4.187 into my temperature of the feed water. It was given as 40 degrees Celsius. Okay, so 4.187 into 40 minus 0 equal to 167.48 kilojoule per kilogram. Now we have now until now what we have found out. Okay, so we have noted the mass of steam, the mean effective pressure, okay, all the given parameters. Then based on the mean effective pressure of the steam that was given. Okay, so I just looked up at the steam tables and I found out that okay, my condition of the steam which is there. Okay, so enthalpy of steam that is less than the enthalpy of saturated steam for the PS of 7 bar. Okay, so hence the condition of the steam I conclude I obtain that the condition of the steam at outlet it was wet steam. So when I am talking wet steam, then I should be finding out the dry. I have to look at what is the dryness fraction. So I am obtaining the dryness fraction of the steam which is there as 0.91. Okay, then I am finding out the evaporation rate. Okay, so I'll be requiring the evaporation rate when I'm calculating my equivalent evaporation, as well as when I'm calculating my boiler efficiency both. Okay, so then I'm finding out what is the enthalpy of the feed water at the boiler inlet. Now what we can do is that now we can proceed to find out the equivalent evaporation. So equivalent evaporation, okay, the expression D is denoted as ME equal to MA into H1 minus HF1 divided by 2257 kg of steam per kg of cool. So here my equivalent evaporation implies ME equal to H1 is 2570.7, which is given in the question, minus the enthalpy of the feed water at inlet we just found out, okay, 167.48 into 10.4 and dividing it by 2257. So my equivalent evaporation is that I am obtaining it as 11.074 kg of steam per kg of coal. Next, we have to find out the boiler efficiency. What is my equivalent now for a discussion? Okay, so what is my equivalent evaporation going to tell me? Okay, so now already in the condition of the steam, that is in the condition of at the pressure of 7 bar, which is there. Okay, so at the pressure of 7 bar, I am having an evaporation rate of 10.4 kg per kg of coal, kg of steam per kg of coal. So now if at all my pressure which was there, okay, so the same kind of steam, which is this same condition of the steam, okay, if I want to obtain that similar rate, okay, I'm having that same amount of steam and the coal at uh, instead of 7 bar, if I'm actually considering it for 1 bar, then how much will be my evaporation rate? So when I'm considering 1 bar, students, so my evaporation rate becomes 11.074, okay, kg per kg. So that is what is meant by my equivalent evaporation. Next, which is that I will be going to our boiler efficiency. Okay, so my boiler efficiency denoted by F eta boiler, given as the expression is Ma into H1 minus HF1 divided by the calorific value of the fuel which is there. MA we have reduced as 10.4 into 2570.7 minus 167.48 divided by the calorific value of fuel. It is already given in my question. Okay, so it is given as 30,000 kilojoule per kilogram. So students, the boiler efficiency which is there, okay, so we are and then to convert this into percentage, okay, so multiply by 100 into percentage. So my boiler efficiency is there, I am getting it as 83.312 percentage. Okay, so which is a very good efficiency, considering that here in this in my question, okay, so I am having just my boiler, okay, I do not have any of the accessories. So if at all generally, okay, when I'm adding the superheater which is there, okay, so on a general note, when I'm adding a superheater, okay, so superheater after my boiler which is there, so that adds to around 6 to 9 percentage of to the efficiency. That adds around 6 to 9 percentage to the efficiency. Then if I'm adding the economizer which is there, okay, if I'm adding the economizer, that also adds to the around which is that adds to the actually increases the temperature of feed water at the inlet. So that indirectly, okay, that adds around 6 to 8 percentage of to the efficiency. So without those superheater and economizer and air preheater itself, my boiler is giving such a good efficiency. Okay, so now a quick recap. So in my question which is there, I was given the boiler, how much is the mass of fuel evaporate, mass of coal which is used, and the mass of steam, mass of the water which is evaporated in 24 hours. Then I am given the steam pressure and I am given the enthalpy of the steam also. Then I was given the feed water temperature as 40 degrees Celsius and the calorific value of the fuel. I am supposed to find out equivalent evaporation and the boiler efficiency. So firstly, we are writing those terms. Okay. Then from the pressure of the steam which is there, we are finding out that we are able to deduce that my steam which is there, it was wet steam at outlet. So once it is wet steam, so then and I am finding out the dryness fraction of steam. After finding out the dryness fraction of steam, I am finding out my evaporation rate which is there. So my evaporation rate, it is 10.4 kg of steam per kg of cold for the 24-hour duration. Then the enthalpy of feed water at boiler inlet, which is there, that is 167.48 kilojoule per kilogram. Then using the expression for equivalent evaporation, which I am getting my equivalent evaporation for this particular conditions as 11.074 kg of steam per kg of cold. Then I am finding out my boiler efficiency, and the boiler efficiency I am obtaining as 83.312 percentage. Okay, so with this we will be concluding this problem.